Okay, so again, continuing with increasing the surface area, you'll have more places where the reaction can take place. This means you have increase in the number of collisions per second, more successful collisions, increasing the rate of reaction. Alright, fairly straightforward. So again, refer to the last bit of that video. You have more places for where the reaction can take place. Remember that large cube, splitting it up into 4 smaller cubes. Alright, so we now looked at how increasing the concentration, temperature, and surface area can affect the rate of reaction. There's one special example. It's if the reaction only involves gas particles. So if the reaction only has gas particles, you can increase the pressure. And if you increase the pressure, I'm going to draw a little example here. So say, for example, this syringe, and you're trying to push the end of the syringe that way, and obviously it's just going to be air and gas in there. If you push it, meaning you increase the pressure, what you're doing is you are squashing the particles closer together. So if the reaction only has gas particles and you increase the pressure, you squash the particles closer together. And if you squash the particles closer together, then you increase the frequency of collisions per second. And again, that increases the number of successful collisions, meaning you increase the rate of the reaction. So this example only refers to if the reaction only has gas particles, and if you increase the pressure, you're basically squashing the particles closer together, increasing the frequency of collisions per second, number of successful collisions, increase the rate of reaction. That's it in terms of looking at how different factors can affect the rate of reactions. Okay, so this pressure one only applies to if the reaction only has gas particles. Now the last little bit of C3C here is looking at a catalyst. What we already know about a catalyst, it helps to speed up a reaction. So catalyst. It speeds up the rate of reaction without being used. That is the key thing. Without being used in the reaction. What that means is it can be recycled and used again and again. Now, for catalysts, you want to think of it as being specific. So what that means is different catalysts will speed up different reactions. So they're specific. Speed up different reactions. Now you might have learnt this already in the biology section if you looked at it a little bit on enzymes. But the example that we want to think about here is lock and key model. So in most instances, one key will open up one lock. And that's the same thing with the catalyst in that they're being specific. So just because it speeds up one reaction doesn't necessarily mean it's going to speed up all the reactions. So key thing speeds up the rate of the reaction without being used. So it can be recycled, and they're specific. So different catalysts speed up different reactions. And that's it.